Hi, greetings. My name is Arun, and I just want to record my understanding of second order cone programming. So I crawled internet and I couldn't find the visualization for this constraint. So here, if you can see that this second order cone programming, the objective function says that it is linear, and we have to minimize, and it's subject to this constraint, right? It's subject to this constraint where it says that it is a cone. So sometimes I crawled internet and I found out that there is no such visuals available. So I thought just to record this session for my future understanding and for those who are really interested in deep visualization of this constraint. So this is like what it says, that you calculate the norm of some constraints, right? And then it should be less than the affine function. And it says that it is a cone. Now, if you just think over it and visualize it, it is a bit hard to visualize, right? For an example, when I just what I did just to visualize it, I thought just to take two constraints. One is I what I just what I take just I define two hyperplanes, right? And because this is a matrix A, and each row you can see it as a hyperplane, right? So if so I have taken a matrix A 2 by 2 where each row is a hyperplane, and then I defined those hyperplane. Then what I did then, for each point I found out the distance of that hyperplane of a given point from those two hyperplanes, and then I take the norm of by keeping them into a vector, right? So just to visualize, this is how what I did. This is what we did. Just a minute. Mhm. Okay. So if you see that there are two hyperplanes I defined, it is x minus y minus 1, which is this hyperplane given in this purple. And the other hyperplane is this x plus y minus 1, which is given in blue, right? So this is on the left hand side of the given constraint in that cone programming. So if I need to calculate the norm of a vector, what I am doing is, like, for example, this is my point is -4 2, right? -4 2. So I will calculate the distance from this hyperplane. Let's say d1, and the distance from this hyperplane, let's say it is d2. And then what I will do, d1 square plus d2 square root. It will give me the norm, and it should be equal to the some other affine function. So just for the sake of simplicity, I have defined my affine function is x equals to 1. So it is nothing but x minus 1, right? So this is a green function here, right? So if I put my constant like this, so this my affine function on right hand side of the cone constant will be x equals to -1, right? So now if I just plug all these things in my Matlab, right, and I want to visualize it, so this is what you can see now, right? This is just a minute. So here, if you see, this is what I'm seeing. This is a Matlab function here. So I plot it here somewhere. So it is a cone, right? Just a minute. I think it is not visually clear. First, I need to show you a code. Where is the code? Where's the Matlab? Oops. I cannot see this. Okay. Just a minute. Just a minute. Okay. What I will do, I will just copy this code somewhere here on this notepad, and then I will show you. Don't worry, I cannot share that thing to you. So so here, if you can see, here if you can see this is a code I just so what I did, I hope this is visually clear to you. So what I did, I just defined a mass grid, and then uh, this is my first plane, hyperplane, right, Z1, and this is my second hyperplane, Z2. Then what I did, I just calculated a norm of distances for each point from these hyperplane, right, Z, and then this plane on the right hand side of the cone constraint, right, this is Z x-axis equals to -1, let's say this is -1. So this is my third constraint on the right hand side. So this constitute a matrix, and if you do calculate the norm of this A matrix, it is ax plus bi, it will give you some 2 by 1 vector. You calculate the norm, it should be always less than this third affine function, right, cx plus the bi, something on right hand side which I have shown you there. Then I just wanted to filter all those points where my z3 is always greater than my um, left hand side norm vector. This is my z, and then as a filter I just pass z1, and then I plotted it, right. If I plot that thing, so if I plot that thing, then what I got is this thing. Just hold on. +1. Right. So now if I plot this thing, this is what I will get. That's it. So if you just first visualize that thing here. So this is my function here, which is on the right hand side of that constraint programming, right? You are, this is on the right hand side of the constraint programming, and left hand side was my two hyperplanes. One was x equals to y -1, and then is x plus y equals to -1, somewhere right here. So this is my center. I calculated the norm of distances from for each of the point, and I said that it should be always less than equal to my affine function somewhere here, right? So if I filter it, then on the what I get, these are the points which I got here, and you see it is, this is a cone, right? This is a cone. Can you see this is a beautiful cone here? And if my constraint is actually the observations, what I found here is, if my right hand side constraint, right, if this affine function is directly go from here at the origin of this cone, then I will not get any point. I will not get any point. For an example, uh, without filtering, if I show you a cone, without filtering, if I show you a cone, this is how it looks like. So this is how it looks like. Okay, this is Z1 plus Z2. Okay, this is what it should be. So this is the without filtering, right? So I hope this is, you may be seeing it. So this is without filtering. So this was my cone, and it is on the left hand side of that cone constraint, second order cone constraint programming. So I have not applied right hand side on this so far. The moment I applied right hand side, what I say that this is a cone, right? Then I applied right hand side, it says that it should be it should be always, this norm is always less than some given constant affine function. So I'm putting some affine function here, right? X equals to uh, plus X somewhere here, right? If I put a constant somewhere here, so all these points on the right hand side will get filtered, and you will see this cone. And for an example, if I put a constant at 0.5, right? So if I do at 0.5, 0.5, then what I will see is just double it. Z1. Yeah, here we go. Just hold it. Oh, yes, there it is. Yes. So and right now I am just pushing my constraint on like from 0.5 it is going my constraint. So here you can see the only this is the visible points which is visible here. Right? These are the visible points. So that's it. I hope. Yeah. So this when it goes from 0.5, so all these points are visible from here. This is all my observation. Please drop me a comment if you have any confusion. I will share my code on the GitHub. Thank you very much.